The S3 bucket that we created is either in US East 1 or possibly somewhere else if you made it somewhere else, and that doesn't really matter. But as we've kind of referred to along the way, some places are further from Virginia than others. There's a free geography lesson for you. Not only are we front-end masters, but also geography masters is our next product that we'll be launching soon. Takes people longer to get those applications because of physics. Yes, computers can get faster, but electrons are only going to move at max at the speed of light. So turns out like we're probably not getting around that one until quantum computing really, and all sorts of other physics has to happen to make that happen. Also, even then, they don't just go through the air. There's a series of tubes, or really cables, but let's go with tubes. That get all of our bits and bytes everywhere. So you have a few options. Is you could make a whole bunch of S3 buckets, right? Put in like S3 buckets around the world. Or if you think about where your API is going to go, you could theoretically pick where you thought your customer base was going to be. And that's an option, right? And for some of your like server-side stuff, if you're not using some of the globally distributed databases, like I think Dynamo has a globally distributed option. I think Aurora, their SQL database, you can also have a global option, but they have limitations. For some levels, you have to do that, for also like disaster recovery and stuff along those lines. But as front-end engineers, we don't got to worry about that. We're putting text files on the internet like it's the 1990s. Right? We can just put those text files everywhere. That's going to be what we do. So CloudFront has a ever out-of-date map. This is not the out-of-date version of it, but like at any given point it could be out of date. I think last time we did this course 3 years ago, there was 144 edge locations. Now there's over 300. Right? So there's just basically little kind of data centers spread throughout the world, and we're going to put our app on all of them easily, right? I mean, we're technically not, but it's really not important. That's the detail. So let's kind of look at the before and after of a real-world application that we had that I took some measurements for, which is you can guess that it's probably in around US East 1. See, the green is all close to like the east coast of the United States. And the further that you get, the longer it even takes like the initial, this is time to first byte. So this isn't even the entire time to get the application. This is time before the very first byte hits their browsers, right? So it's like it's over 10 times, almost just shy of 20 times worse in kind of Australia and some parts of South Asia. That is before CloudFront. This is after, right? So you see a lot more green in this case as well. CloudFront also supports HTTP 2 out of the box. What is that, and why is it great? So the way that it worked before HTTP 2 is you send a request for a thing, it sends you some bytes back. You send more bytes out, send another request, it sends more bytes back. It can do one thing at a time. Browsers cheated for a while, and they still cheat, and they'll open up 6 of those connections, right, to try to get you 6 times as much stuff in parallel. But even then, they give up. And so there used to be a whole bunch of tricks. If you really want to optimize your performance, you put your images on one subdomain, because it'll do 6 to a given domain. You put some of your images there, and you put your CSS there, and you start to break stuff up so you can have more than 6. Well, so then there's HTTP 2, which is just like, what if we just like multiplexed all this, and like we'll just send you everything kind of as a constant stream in an open connection. That is how HTTP 2 works. There's some other bonuses. So we talked about you pay for requests from S3. You pay to get data out of S3. CloudFront, if CloudFront serves that request, you're not hitting S3. And it's way cheaper to serve it from CloudFront. I think it's like there was, is it 5 gigabytes of free transfer? I remember off the top of my head. I had the slide earlier. Terabytes, yeah. Of transfer. I thought it was the biggest file size. Whatever, we can figure it out. But it's a lot cheaper, and yeah, it won't hit your S3 bucket at all, right? The other part that's nice is it's not just about the distance. When you normally would go hit your server in US East 1 or wherever, right, or wherever you were hosting your assets, your request has to go through the public internet with all the other public internet traffic. Gross, right? When you're using CloudFront, it hits the CloudFront Edge node, and then Amazon has their own private cables that it goes through. Yeah, right? Fits with your mental model. And goes through and kind of gets all the bytes. So it's usually faster even to get to wherever the S3 bucket is over Amazon's private networks than it is going over the public internet as well. So keeping requests from going to S3 in the beginning is obviously cheaper because it reduces our cost because we're paying for requests out of there. At the same time, it's also faster when it does have to go there. And we'll kind of look at another chart real quick. So the other kind of cool part about how it works is there's like multiple stops along the way, which is you had all of those little intermediate nodes, which are kind of shown right here. Then you have these, see these bigger yellow ones? These are the regional edge caches, right? Which is, so let's say they go to hit this one right here, and it's not there. It's not going to go all the way back to Virginia. It's going to go to the closest regional edge cache first. So somebody requests a file. If we have it right near them, give it to them immediately. If we don't have it right near them, OK, go to the regional edge caches. Do we have it somewhere close to them? No. At which point, go all the way back to Virginia. And then on the way back the other way, we'll put it in all of those places. So when I said that little thing before about how like we're going to put our application all over the world, well, technically not. We're going to put it in our bucket. But as it like goes through all the different edge nodes to get to our customers, Amazon's going to leave it in all of those places so that when future requests come in, then we don't necessarily have to pay that cost. Cool. One other quick note is just to talk about headers a little bit. Generally speaking, CloudFront's going to ignore most of the request headers, right? So anything in there around like any special header you might rely on. We don't rely on any for the purposes of what we're building today for our static assets. I mention it because it will just drop them. Why? It will drop them because it's trying to figure out, do I already have something in either the regional edge cache or the edge node that I can just give them? By caring about necessarily maybe the cookie or what user agent or something along those lines. If it's the same JavaScript file, I don't care that they're using Safari versus Chrome. Just give them the JavaScript file, right? So it tries to ignore as much about the request as it can possibly get away with. And that is almost always the right case. I only mention this because if there is like, no, our app, we need a special header to get set for like authentication, you do need to like allow that through, and so on and so forth. It will also add in some of its own headers after it hits the edge node. And you can take a lucky guess what sets these to true. I'll leave that as like an exercise in this case, which is if it's a desktop viewer. And so you can do stuff when we get to the lambda edge kind of stuff a little bit later, where you can like maybe shrink an image, right? We'll kind of mostly talk about some of those things because the actual like writing image resizing code is its own thing. But you can kind of like get a little bit of knowledge about where it's coming from and do some really interesting stuff with the request itself as we go through. All right, cool. Let's go check on our CloudFront distribution, shall we? So let me go back to CloudFront. And we'll go ahead and we'll check out our distribution. And so I should be able to grab this domain. And we can see that it works in this case. And super awesome .click should work as well. What happens if I do HTTPS? HTTPS now works. We have that little lock up there as well. I'm pretty sure we set it to redirect, but I also might have old DNS records in here as well. So we can figure that out in a second. But yeah, So now our app works. Super awesome. A click. It is secure with HTTPS. We can go refresh one of these pages. In this case, it still works, and everything is pretty good. That's good to know. So now this is all kind of in place. Right. Does that now, is everyone else's distribution? You need a second? All right.
Can you show where you associate CloudFront in Route 53 again?
Yes.
Real quick? I had to regenerate my SSL.
All right, yeah, I'll show that one more time in case you had to regenerate your cert. So we'll go into Route 53. Go to registered domains. Now mine will be set up in this case, but we can still kind of show where. We go to manage DNS. Click that little button, because just, then you hit view details. Then you find the A record. So we got two of them. We got the regular bare domain, and then we've got the www. Go there, we'll edit the record. And the alias, instead of to an S3, should be CloudFront distribution, and that should then be the autocomplete in that case.